Okay, in this video I'm going to continue on with exercise 6b of the book Fundamental Applied Mathematics. We're on page number 162 and the question is 9. It reads, a small ring is threaded on a smooth piece of wire which is bent to form a circle of radius 5 meters. The ring is projected from the lowest point on the wire, which is held in a vertical position with speed 14 meters per second. Find the speed of the ring when its height is the same as the height of the center of the circle. Secondly, show that the ring will just reach the highest point of the circle when it comes to rest. So I'm going to call the height at the center of the circle number 3, the height at the top number 2, and the initial point number 1. We know that the radius of the circle is 5 meters. So just to be awkward, I'm going to define my zero gravitational energy here. The reason I'm doing this is to show you that that it works. It doesn't matter where you define it. So U grav here is equal to 0. Alright? So of course you can define it here or here. It doesn't make any difference. Just pick one and go with it. But I'm going to define it there. So as a result, upwards is positive gravitational energy and downwards is negative. So in this case, both points 3 and 1 have negative gravitational potential energy. So let's apply the principle of conservation of energy to this. So it's going to be, we'll say the kinetic energy at 1 plus the potential energy at 1 is equal to the kinetic energy at 3, that's supposed to be at 3, plus the potential energy at the point 3. So a half m times 14 squared plus m, now actually it's, okay, mg times h, but the thing is, we said it's a negative gravitational energy, so its h is, it's negative, and its displacement is going to be twice the radius of the circle, which is going to be 10 meters, is equal to the kinetic energy at 3, I'm going to call that half mv squared, plus the potential energy at 3, so it's going to be mg times 5, but once again we're in a negative direction. Alright, that's pretty straightforward stuff. So I'll pull out my calculator. Will I even need to do that? No. So this is, actually no, I will altogether, right? So we're going to go for 14 to be squared divided by 2, so that's 98, minus, cancel across m's of course, so it's going to be 10g is equal to mv squared over 2 minus 5g. So let's see what that happens. So that's going to be 98 minus 5g times 2 divided by nothing. I didn't need that line at all. And that's going to be equal to, if you square root that, we're going to get equal to v. Now I know I did that a bit backwards, but I'm sure you understand what I'm doing here. Alright, so I just brought up the 2 and I square rooted the whole thing. So 98 minus 5 times 9.81 is 48.95. Multiply that by 2 and square root that answer, and we get an answer of v is equal to 9.9 meters per second. Alright, so I'm given an answer of 7 root 2 here, so let's multiply this by 7, and 9.9, that's the right answer. So you can see of course that we're getting the same answer by defining my u grav as being at the very top. Alright, so let's go ahead and calculate the velocity of the particle when it's at point number 2. So once again, I'm just going to straight into it. So the half mv squared, so that's 14 at point 1, is plus the potential energy at point 1, so that's negative mg times 10 is equal to the potential energy, which is 0, plus the kinetic energy, so I'm going to say half mv squared. Because at point 3, or excuse me, at point 2, the kinetic energy is maximum, but the kinetic energy is half mv squared, excuse me, but the kinetic or the potential energy is equal to 0. I know I'm getting my potentials and kinetics confused, so just please bear with me. Alright? So what I'm going to do here is, that's squared, believe it or not. That was 98 as far as I know. Alright, so let's do it again all together. So it's going to be 14 squared divided by 2, 98, minus 10 mg is equal to mv squared over 2. I'm going to cancel across my m's and multiply across by 2. So 98 times 2 is equal to 196, minus 20g is equal to v squared. Okay, so v is equal to the square root of 196 minus 20g. Alright, so that's pretty straightforward stuff. Let's just plug that into the calculator again. 196 minus 20 times 9.81, and square root of that answer. Oh, that's actually 20 times 9.1 second now. 196 divided by 20. Okay, so if you notice here, we're supposed to get 0. Now, if I define gravity as 9.81, this number here is larger than this. But if I define it 9.8, we're going to find that v is equal to 0. Oh, we couldn't see that. V is equal to 0, which is what we're asked to find out. We're asked to find if it's going to be at 0 meters per second when it hits the top, which is correct. Alright, so thanks for watching. Please pass it on to your friends and subscribe to my channel.